Hello everyone, in this video we're going to look at sketching cubics. Okay, so it's quite an important idea. Now when it comes to sketching graphs, whether it be quadratics or cubics or quartics, there's three things that I like to think about. So let's first of all write down the general form of a cubic. So the general form of a cubic is ax cubed add b x squared add cx add d equals 0. So that's our general form of a cubic. Now, the first question number one that I like to ask myself is the coefficient of the a that's in front of the x cubed, is it positive or is the a negative? Because if the a is positive, the cubic's going to have that kind of shape. And if the a is negative, the cubic's going to have that upside down kind of shape. So that's our first question. Is the coefficient in front of the cubic term positive or negative? If it's positive, it will be that way up. If it's negative, it will be that way up. Okay, question two. I like to ask myself the question, when x is equal to 0, what is y? And then the third question I ask myself is, when y is equal to 0, what is x? And with those three questions, you can sketch pretty much any quadratic, cubic, or quartic. Okay, so let's look at example question 1. So in question 1a here, we have got a cubic, as you can see. And the first question is, question 1, is the coefficient in front of the x cubed going to be positive or negative? Well, if this bracket was all expanded, we would have x times minus x times x. So that would be negative x cubed. So that means it's going to have that kind of shape. Okay, so that's our first question done. I'll write down 1 for question 1. Question 2, when x is equal to 0, what is y going to equal? And in this equation, you can see here, we would have minus 2 times by minus 1 times by 1, which is going to be, oh no, let's have a look. We'd have minus 2 times by 1 times by 1, so it'd be minus 2. So the y would equal minus 2. And where that's come from would be 0 minus 2 multiplied by 1 minus 0 multiplied by 1 add 0, giving us minus 2. Now this is the y-intercept. Okay, so this is the y-intercept. In other words, this is where the graph is going to cut the y-axis. And then our third question, number 3, when y is 0, what is x? So that means we've got x minus 2 times by 1 minus x times by 1 add x is equal to 0. So this is basically just solving it, finding out where it cuts the x-axis. So this is going to be x is 2, 1 is equal to x, and x is equal to minus 1. Okay, so we found the 3 points of intersection with the x-axis here, the y-axis here, so 1 point, and the general shape. Now this is enough information for us to be able to piece all of these pieces of information together to do our sketch now. So we can see it's going to intersect the x-axis at minus 1. It's going to intersect the x-axis at 1. It's going to intersect the x-axis at 2. That's those pieces of information there. It's going to intercept the y-axis at minus 2. And we can see that the general shape must look like this. So we can piece all that information together in order to now sketch our cubic. And that's what it's going to look like. Okay, let's have a look at another one. So let's do question 1, part B as well. So question 1, part B, slightly different one here. We have y is equal to x times by x add 1 times by x add 2. Now, it's worth pointing out that for any quadratic, cubic, or quartic, when you've got an x on its own outside the bracket, the graph is going to go through the origin. So it's just worth bearing that in mind. Now, question 1, is the coefficient of x cubed going to be positive or negative? We've got x times x times x, so the coefficient is going to be positive, so it means it's going to be that way up. Question 2, when x is equal to 0, what is y going to be? Well, when x is 0, y is going to be 0 because it goes through the origin. Nothing times something is nothing. And then finally, when the y is equal to 0, what is the x going to equal? So we have x add 1, x add 2. So this is going to give us x is 0. This is going to give us x equals -1. And this one's going to give us x equals -2. So we've got our 3 pieces of information. So we can bring those together now in order to draw our sketch. So let's do our axes. Here they are. It's going through the origin. That's that one done. Goes through -1 and goes through -2 over here. So it's going through the origin, going through -1 and going through -2. It's got to have that kind of shape so we can bring that information together. And the thing that's going to fit that pattern would be a curve that would look like that. So that's our question 1 part B done. Okay, next, what I have called question 2 here. Now, what's going on? So in question 2, we've got a new idea that we need to introduce. And the idea that we need to introduce is that notice we have a squared term, okay? Now, when you have a squared bracket, so it means that you're going to have a repeated root, which means that there's going to be a part of the curve that's going to be a tangent to the x-axis, okay? So whatever this curve looks like, just to draw a rough sketch, it's going to have some kind of a tangent to the x-axis. And at the moment, we can't tell exactly how it's going to look. It could be, for example, look like either one of these scenarios, okay? So it could look like that, or it could look like that. But we've got the squared means that we have a tangent to the x-axis. So that's the new piece of learning to look out for in this particular question. Okay, let's start it then. So question 1, what's the coefficient going to be of the x cubed? We have x -1 all squared. I'll just write what it is. X -1 all squared times by x add 1. So x -1 all squared times by x is going to give you a positive coefficient of the x cubed. So it's going to be that kind of shape. Okay, that's our first thing. Next, what do we need to know about the next thing? So the next thing is question 2. When x equals 0, what is y going to be? When x is equal to 0 here, we're going to have -1 squared plus times by 1 rather. So that is going to equal, it's going to intersect at 1. So the y-intercept is going to be at the coordinate 0, 1. Our third question is when y equals 0, what is the x? So we're going to have 0, open bracket, x -1 squared, and x add 1. So that's going to give us 2 solutions. They are x equals 1, which is our repeated root because of the squared, and x equals -1. Okay, so let's bring all that information together into a sketch now. Bringing it all together, it must be that way up. It has a repeated root at 1. Okay, so here at 1, it's going to just touch the axes. It's going to go through the coordinate 0, 1 up here, and it's going to go through -1 as well. This is the repeated root, so bringing that information together, our cubic must look like this. There we go. That's how we deal with a squared where we have a repeated factor. Okay, good stuff. Now let's have a look at question 2, parts B and C. Talk about those. So question 2, part B. Right, now we've got something here that is not factorized. So we have x cubed -2x squared minus 3x. The thing to note here is there's a common factor of x. So let's take that out and then see what we're dealing with. And then we're going to see, does the quadratic that we've got left behind factorize? Okay, that's our question. Does the quadratic that we've got left behind factorize? And it does. We have x -2 minus 3, two numbers at times together to make -3, but add together to make -2 is -3 and +1. So we have x -3 and x +1 times by x. So we factorized our cubic. So now we're ready to ask ourselves our 3 questions. Number 1, x times x times x, the coefficient of x cubed is going to be positive, so it's going to have that kind of shape. Question 2, when x equals 0, y will equal 0, because we'll have 0 times something times something. So this one's going to go through the origin. It's going to go through 0, 0. Number 3, when y equals 0, what is x? Let's have a look at that. So when y is equal to 0, we can have 0 is equal to x, x minus 3, x add 1, which gives us, that is going to give us x equals 0. That's going to give us x equals 3. That's going to give us x equals minus 1. So we can bring all of this information together now to do our sketch. What do we know? We know it's got to be that way up. We know it goes through the origin. We know it goes through the coordinate where x is 3, and it goes through the coordinate where x is minus 1. It has that shape, so the curve must look like that. So that is our question 2b. And finally, in this little video, 2c. 2c is, you could expand the whole thing and go through the whole process that we've just done. That would be fine. But this is easier to think about this one as a graph transformation. Because if, for example, y was just equal to x cubed, what we would have is a cubic graph like that, okay? But what we've got here is we've got a transformation of the type f of x add a. Now this is a translation by vector 0 minus a, which means that the whole graph is going to move a to, in this case, the right, okay? So the whole graph is going to basically move to the right. So we can say that this cubic is going to be translated to the right, so it's going to look like this, okay? So that is our 2 there. Now, the only thing is, in order to get full marks for this question, we would need to invariably say the points, what are the coordinates of the points of intersection with the axes. So we need to find out what this is. And if you remember, something crosses the x-axis when, the y-axis rather, when the x is 0. So we need to look at our equation, x minus 2 all cubed, and we ask ourselves the question, when x equals 0, what is y? And that would give us y is equal to 0 minus 2 cubed. Minus 2 cubed is minus 8. So that point of intersection is minus 8. Do be careful. If a question asks you to state the coordinates of the points of intersection with the axes, it's probably wise to write them as coordinates. So we should write this one is 2, 0, and this one is going to be 0 minus 8. Just, it's, if they say, you know, label the coordinates, it's always good to be on the safe side, just in case the marking criteria doesn't allow you just to write 2 or minus 2. So that is how we would do some sketching of some cubics. In the next video, what I'm going to do is I'm going to talk about a slightly trickier case. Actually, you know what? Let me do it in this video as well. We may as well. Okay, so rather than making a separate video, let's do the hardest scenario. Okay, now the hardest scenario for sketching cubics is where we have a part of the cubic that is not cutting the x-axis at all. Okay, so let me just bring something in here to show you. I'm just getting the thing that we need here. Just bear with me one moment. So this is our trickiest one that we're about to do now. Okay, so let's have a look at this one. I'll call this question 3. Okay, here we go. Right, now this one, this is the trickiest kind of one here. Okay, that's highlighted in grey there. So what we do with one that's like this is we need to think about the questions that we had before. Okay, so we need to think about question 1, what's the coefficient of the x cubed going to be? Well, in this case, it's going to be positive. So we know that the general shape is going to be like that. Question 2, you may remember, is when our x equals 0, what is our y? And in this equation, when x is equal to 0, the y is going to equal minus 2. So the point of intersection with the y-axis is 0, minus 2. And our third question is, when the y is equal to 0, what is the x? Okay. Well, we can see from the equation that one of the solutions is going to be given by 1. Okay, we can see that when y is equal to 0, that would come from the equation being x is equal to 1 here. But this is our interesting problem. What on earth is going on with this bit? Does this bit cut the x-axis at all? Now, what you need to do here is you need to evaluate the discriminant. You may remember the discriminant is the b squared minus 4ac part of a quadratic equation. And if it's the case that the discriminant is greater than 0, it means that we have the kind of standard cubic where we've got 3 bits like that. If this quadratic term gives us a discriminant of b squared minus 4ac equals 0, that's a scenario where we have a tangent to the curve. But if our discriminant, our b squared minus 4ac, is less than 0, then we have this kind of scenario where we only have one root. Okay, so what we're going to do now is we're going to evaluate the discriminant of this quadratic term. So b squared minus 4ac from this quadratic, our b is 1, so 1 squared, minus 4, our a is 1, and our c is 2. So we have 1 minus 8, which is minus 7. So that is negative. So this is telling us that we have this third scenario here. So we know that this quadratic is going to look something like this. Now, it is hard to say exactly what the quadratic is going to look like, because it could look like that, but then again, there's other alternatives. It might be that it looks like this, for example. Okay, so it could look like that one, or it could look like that one. And if there isn't enough information in the question given to firmly decide whether it's this version or this version, you'll get the marks for whichever way you draw it. Okay, so sometimes there are a couple of possibilities that it could look like, but they will give you the marks whichever way you draw it if there's not enough information to narrow it down. So let's bring the information together for this question now. What do we know about it? Well, we know that it is going to be that positive kind of shape. We know that. We know also it's going to cut the y-axis at -2. We know it has a solution at x is equal to 1 there. Okay, so we can kind of bring that information together and draw some version of what it might look like. So it might, for example, look like that. So if I drew it like that, that would be fine, and that would get me all of the marks. Yeah. As an alternative, just to so you can see a different version of what it could potentially look like. Okay, so it could potentially, however, look like this. And both of those would be fine. You would get full marks for drawing both of those because there's not quite enough information given to be able to decide which one of the two it is. But the marks would be for the correct points of intersection with the axes, the correct general shape, and identifying that you have this turning point here as not intersecting with the axes. So that would be like the 3 marks that probably would be allocated for that particular question. Okay, I hope that you found that helpful. That is all of the scenarios that you're likely to encounter when sketching a cubic. And I think perhaps in the next video we might talk about quartics. See you in the next video.